In this demonstration, you'll learn how to set up a static structural simulation to study the results of pressure loading on a curved pipe. I'll start by selecting a simulation process template from the study panel on the left here. I'm going to select the structural template. I need to import a geometry file, so I'll leave this set to the default. This option is enabled by default so that you can modify the imported geometry from the Geometry task. I am running a structural simulation only, so I won't select another physics type. I can either do a static analysis or a modal analysis. For this example, I'll select a static one. And accept the default selection for the options list so that contacts in the interface of the bodies are detected automatically. I will then apply the template and create the simulation process. In creating my simulation process, the first thing that I'm asked to do is select a geometry. I'll select the Design Modeler Geometry file for the curved 3-part pipe. AIM loads the geometry and sets up a simulation process with typical default settings for geometry, mesh, physics, and results. While this is not a particularly time-consuming process, it is not interesting to view, so I'll skip ahead. AIM has automatically created the physics solution process. Here's a summary of all of the tasks created along with their status. All of these tasks are also available in the workflow window in a data flow diagram format. Because the meshing task has all the information it needs to produce the mesh, I'll go ahead and update it now. The meshing task is now complete. My physics solution task, the red exclamation mark here, is telling me that it needs more information in order to complete the simulation. I'll click on it to go into this task. You'll see that a lot of defaults have already been set up for me: material assignments, physics options, interface conditions, and solver settings. You can also see that 2 contacts were created for this case. The blue button suggests our next step. Here, I need to add some loads and constraints. First, I'm going to add a displacement constraint. I'll use the face selection filter to select the face at each end of the pipe. Then I'll add the displacement constraint from the context menu. The displacement constraint is now up to date. Next, I want to apply a pressure load to the inner curved faces of all 3 bodies. I'll start by selecting the 3 outer faces and hiding them. Now I'll select the inner curved faces of all of the 3 bodies. And I'll right-click to add a pressure load. I'll set the pressure and then press Enter. You can see the magnitude value is also reflected here in the pressure panel. The pressure load is now up to date, and with these few additional settings, my physics solution is all set up. Before proceeding, I'll want to show all bodies again. And then I'll solve the physics solution task. I can see the progress on the bottom right-hand side here. Everything's updated, so now I can view my results. I'll click on the Results task and then Evaluate. I can then expand the Results heading to view the predefined results. One predefined result shows the displacement of the pipe under the load. I can use this pull-down at the top to select my other results. I've got equivalent stress here. And, if I like, I can click the Play button to animate my results. I can also add the force reaction result to view the reactions generated at the 2 fixed ends of the pipe. I'll right-click and add that result. Then I can evaluate and view the force reaction. This concludes this demonstration of an end-to-end basic static structural simulation in AIM.